Good morning, everybody. Today we'll talk about scalars and vectors in physics, which is very important. So until you know the difference between a scalar and a vector, we can't do much of the problems in physics. Let's see this. If someone asks you, what time is it now? You may say it is 9 a.m. So, if you ask him what's the direction of this time, you'll not be able to tell because time has no direction. So the point is, such physical quantities which can be expressed with a number and a unit is called as scalar. So you can say how much time has elapsed since you have started the video. You can say about 15 seconds. So 15 seconds. Seconds is a unit and 15 is the number. So any physical quantity that has a number and a unit may be associated with the unit, may not be associated. But a number is definitely a scalar quantity. Now we have in physics some quantities which are having both this type of value, which is called as magnitude, and also a direction. For example, I am pushing this wall, so with a force of 10 newtons. Then also I am saying that I am pushing it in a direction towards north or towards east, towards west, some direction. So a physical quantity like force. So force is having a number like 10 newtons and a direction towards north or towards east, something like that. So therefore, a magnitude or value with the unit and the direction. So this is called a vector quantity. So in physics, vectors are very, very important. Let's see how to represent a vector. A vector is represented in two methods. One is algebraically, the second one is by graphically. Algebraically, a vector force I can represent with F bar is equal to, or F with an arrow mark like this, or with a bold letter F, this way. So these are the three ways you can represent a vector. So I can represent A bar vector. But whereas A, letter A, is not vector, it is a scalar. So the vector portion of the scalar is this one. So like force F bar has a scalar quantity and a direction. So therefore the scalar quantity can be represented with a normal letter without any bar on that. Then what is the method of graphical representation? I can represent a vector with a straight line with a length of 10 newtons, means I can put it as 10 centimeters length or 10 inches length or something like that, and then with an arrowhead on that. This is called tail of the vector, this is called head of the vector, and the length is the magnitude of the vector. So why should I choose 10 newtons, 10 centimeters? Why can't I choose 5 centimeters, 5 inches, something like that? Yes, you can do that. But you have to write the scale there, that 1 centimeter corresponds to how many newtons. So for example, in this case, if I say this is 10 centimeters, let's say it's 10 centimeters, more than that, but if I say it's 10 centimeters, then this is 10 newtons, this is 10 centimeters. So 1 centimeter equals 1 newton. That's how the scale should be represented. So this is the graphical way of representing a vector. Should I have to draw always horizontal in this one? No, a vector can be vertical like this. It can be at some angle like this. It all depends upon your coordinate system. The system in which you're placing this vector and which way is north, which way is east, which way is south, etc. We will continue this topic in the next class with much more details about vectors.